This is Mr. Anderson for Keller Community College. We're going to do some problems in Chapter 2, Section 5, which is on page 126 if you're looking in the 9th edition book. We are going to do problems 57 and we're going to do problems 61, and then we will do problem 65. So the question in this section says, or the heading in the homework says here, write an equation of the line containing the specified point and perpendicular to the indicated line. As before, in the previous video, I am using a mouse, so I do not have a stylus. So this is going to be a little tricky here when I do problem 57. Again, it'll look just a little worse than normal here. The point in the problem that we have to travel through is the point 3, 1. And the line that we have to be perpendicular to is 2x minus 3y is equal to 4. Now what makes this problem just a little bit more tricky is that they give us an equation of a line that we have to be perpendicular to, but we don't actually have the slope. So what we have to do is find the slope by taking our equation and solving for y. So we have to get the y by itself so we can see what the number is in front of x. So we subtract 2x from both sides. That simplifies to 0 on the left-hand side. So we have negative 3y is equal to negative 2x plus 4. Divide both sides by, or everything, I should say. Divide everything by negative 3. There we go. So the negative 3 simplify, so y is equal to 2/3 x, which is, taking two negatives to make a positive, minus 4/3. Now this is our original line with our original slope, and we're going to go perpendicular to this. So the y-intercept, we're not going to use it. It's just there for the problem, but what we do need to see is we do need to see our slope is 2/3. So our perpendicular slope would be negative 3/2. If we were going to go parallel, they would be the same slopes, but since this is perpendicular, we're going to go negative 3/2. So what this gives us here is this gives us a y equals mx plus b equation. All right, and we're going to plug in our slope. So y is equal to negative 3/2 x plus b. And we're going to go through the point 3, 1. So what we will do here is we will plug our 1 in for y and our negative 3 in for x. Or sorry, our positive 3 in for x. All right, so this gives me b here. So we got 1 equals negative 3/2 times 3 using our graphing calculator, or knowing top times top, bottom times bottom. This is negative 9/2 plus b. So we're going to then have to add the 9/2 to both sides. Add the 9/2. And 1 plus 9/2, we can't add these two together because 1 has a denominator of 1. So we're going to change that into 2/2. Because we figure out we need our denominator to be equal to 2. So that means we're going to have to multiply the top number by 2 and the bottom number by 2. So 1 becomes 2/2. Plus 9/2, those simplify, makes 11/2. So our b is equal to 11/2, or 5.5. So now that we know our slope, which is this, and our y-intercept, which is this, now we have a perpendicular line. So you notice that the slopes are opposite reciprocals of each other. And we have our new y-intercept, 11/2 or 5.5 if you wish to write it that way, which will then be perpendicular to the other one and go through the point 3, 1. All right, so there's our first of 3 problems there. Let's erase that, do the second one. The second one, problem 61, is going to be trying to go through the point 1, negative 3. This is the perpendicular line needs to travel through this point, and the original line of problem 61 is 3x minus y equals 2. All right, so what we need to do is subtract 3x from both sides. All right, so the 3x's simplify, and then we have negative y is equal to negative x plus negative 3x. Oh, made a little mistake there. Plus 2. There we go. So we used inverse operations to subtract the 3x from both sides. The 3 simplified. Now we're going to divide everything by negative 1 because there was a negative in front of the y. So y is equal to 3x, since two negatives make a positive, minus 2. This is our original line. Now, this is not the slope of our new line. Whoa, I tried to make a circle there. Looks like a bad shoe. All right, so what I need here is I need my new slope, and my new slope is going to be negative 1/3. Because this is the perpendicular slope to this slope, but we need to travel through this point. So we're going to write my y equals mx plus b, which will be good when we get to our answer here. You might hear my daughter in the background. She's playing and making some pretty funny noises. Negative 3 is my y. I'm going to plug that in right away. Negative 1/3 is my slope, and my x is going to be 1. What's nice is negative 1/3 times 1 is going to be just 1/3, negative 1/3. So that just means I have to take my negative 1/3 and add it to both sides. So I add my 1/3 to both sides, add my 1/3 to both sides. Now again, negative 3 can't be added to negative 1/3 because they don't have the same denominator. So we'll change that into negative 9/3 because I have to multiply the top and bottom of negative 3 by the denominator here. So negative 9/3 is my conversion of the negative 3. So these simplify, and this makes a negative 8/3 is my new b. Or you can rewrite that as negative 2.6 repeating, or negative 2 2/3. So, and now I know my slope, now I know my y-intercept, so I get my answer of y is equal to negative 1/3 x minus 8/3. All right. So we got one more problem to go, and it's actually kind of a quick one, but it requires actually more thinking than it does actual algebra. Because in problem number 65, this is the point that they want you to send the problem through. They want you to send the problem through negative 3, 7. Negative 3, 7, and they also want you to go through the line y equals 5. So negative 3, 7, and y equals 5. So what we actually have here is we have a horizontal line. That's the line of y equals 5. And we need a perpendicular line to that one, so it's going to be vertical. So since that equation is y equals 5, this equation is going to be x equals something. Now what we're going to need is to figure out what that equation is. Now we know this new perpendicular line goes through the point negative 3, 7. It's a point on the vertical line. So the equation is going to be x equals negative 3. Because this horizontal equation was named because at that moment y would always be equal to 5. So this would be the center, the origin right there, and this would be 5 units up. So this would be the point 0, 5. So y equals 5 runs through every point where y is equal to 5. Therefore, the perpendicular line to that would be x equals negative 3 because it goes to the point 3, negative 7. So in review, this is what we started off with. We started off with a line that was going through the point of 5 on the y-axis, and we wanted a line that was perpendicular at negative 3, that's 1, 2, 3, 7, so the point that was right here. Well, to get that line, we would have to go like this, and therefore this line would be x equals negative 3, because it crosses at negative 3 on the x-axis and goes through the point negative 3, 7. Looks a little bit different when you see it drawn out, doesn't it? But again, there's not a lot of algebra to do here. There's just more thinking about what did they give us? Horizontal line. What do we need? A vertical line. Where does it go through? It goes to the point x equals negative 3 because it goes to this point negative 3, 7. All right, well, thank you for watching.